observation that a family is like a black box. You don't know how some of them work, but they do. Any other connections between these descriptions that you can see?
There's individual parts that are connected together.
Okay, anything else?
Seems to be a boundary.
I must say, this is the first time I've ever seen a brown whiteboard marker. Learn new things every day. Anything else?
The functioning of any given part is going to affect the functioning of the other parts.
Okay. Paraphrase a little bit. I hope that's okay. All right, well, you've done some very good work, and I'm going to turn over to JT now, tell you a bit more, and give some examples of other kinds of systems.
Yeah, so now we're trying to learn about the concept of system. So I like to first to sign up to two examples of the system. First one is the dictionary definition of systems. The dictionary, this is Oxford Dictionary. It says, what is a system? The first explanation is a complex whole, a set of connected things, parts, institutions, or an organized body of materials, the things. So, and that's the dictionary definition of the system. And I like to also cite another example of a definition here. So that's from Wikipedia.
Still more about it.
Screen there, there's a button.
Yeah.
Yeah.
You turn the switch that has the sticky on.
Yeah.
Switch on, switch off, right? Standing on.
This is booting.
Yeah, it's got a
Most
little
likely.
It's a poor choice on my part to turn it off. I apologize. So anyone know any good jokes?
The system engineer went tomorrow.
Yeah, that's
Oh, sorry.
So this system does not work. I'm going to explain that. Okay, so here's a Wikipedia definition of system. So you can see that's more or less similar as a dictionary definition. So this is a whole compound of several parts. We're talking about several parts here. And literally that is compensation as a whole, as a set of things. And pretty much like this kind of diagram here. So this is a system, and you got a surrounding environment that we're talking about boundary here, and just now as an example. And also there are two important things in the system. I'd like to draw another chart here. So what we most likely can see a system as a whole, and if the system that we have some kind of functionality, right, so to work on this. So the system, on any system, should have two important components. One we call inputs. Another one is outputs. And sometimes we also have the third component that's called feedback. Okay, so we're talking about the different things just now for the systems. And the very good example is that so probably the curtain off. You know that anymore. Okay, what Daryl did is a perfect example of a system. So in the case of when Daryl asked questions about your opinion about system, he himself is a system. And he got some inputs from you guys, and he wrote that input to the whiteboard. So in this particular case, he actually processed the inputs. So this big part we call the process of the system. So the system consists of three major parts: input, process, and output. So any system you think about is like this. So what we have just now is that, and we got something. This is a family. You may set a family, or maybe families, or yeah, probably family. So that's inputs. A family, families, probably family. Well, Daryl processed that input and eventually wrote down here as family. And he may end up use different ways, for example, capital F, or maybe use different language. So for example, if I would probably, if you say family, I'm going to write Chinese. Yeah, because my audience is probably Chinese, I go the Chinese family here. So that's, we process the inputs and into a output. So this is kind of a basic concept of system. Yeah, so you can think about other kind of examples of system.
Solar system.
Solar system. So
No, I don't know, what's the input?
So solar system, right?
Not the big question.
So for the solar system, the input, I would say that's sunshine. The system, and what is output? So we're going to turn the input to. Do we still need light or something out as output? So we can turn that,
Perpetuity.
the lights, solar lights, to energy. And that energy can be, kind of power energy can be an input of another system, for example, the project. So we need the solar to operate a system. Yeah, I guess I'd like to Harry to summarize the things.
Well, I guess to make it really simple, has anyone changed their understanding of what a system is based on what we've said?
I still have a question. How do you decide where the boundary should be for a system? What determines the boundary of the system?
I'll let JP answer that one.
So I guess we can also interpret system in different ways. That the system is our understanding of reality. So in order to analyze a system, we should somehow set up a boundary. So if we take another example of just now we're talking about solar system. So if we're just talking about that device that converts light to power, so that we're talking that system. But we may consider the whole project system as a system. If we consider that way, so the light will be input, well, that light is output. If we consider the whole system as a whole. So we may omit that kind of, that conversion, that process from light to power. That answer your question?
Aren't some systems closed without input?
Would everyone comment on that?
Well, yeah, they are closed. Most systems are closed. But I guess this class is an example of the system. That you had an understanding what a system was. And based on what we've told you, you may have a different understanding of what a system is now. And so that's, if you look at this class as a system, that's closed systems, most of them are. Like I have process control background, so most of the mechanical systems are, control systems are closed. But anyways, it's a big subject,
Yeah.
so,
Oh, yeah, it's fascinating.
Yeah. that's it.
So this probably shows that the difference, so that was you, before this class, you have no knowledge for the system, right? And now this is the class, after class, still you, but you got this shiny part, the knowledge as an output.